Hey, today we're going to talk about projectile motion, but we're going to focus on acceleration and not go towards two-dimensional motion or single-dimensional motion. Acceleration is what we're going to focus on today. So for acceleration, it is the change of rate of velocity. So the same way velocity is the change of rate of displacement, acceleration is the change of rate of velocity. And the units for that would be meters per second squared, for acceleration that is. And to find the average acceleration, you would need to divide the change in velocity divided by change in time. Don't get confused by the x's. I'm just trying to say that the average acceleration in the x direction will equal the final velocity in the x direction minus the initial velocity in the x direction divided by the change in time. So do not get confused by the x's. I'm just getting picky over here. Some people assume the velocities in the acceleration are the same direction. I'm just making sure you know that they're in the same direction. So my students will only have to write down final velocity minus initial velocity over a change of time. They don't need the x's. For falling objects on the earth, it is negative 9.8. That is only an average value. It is not a true value for all parts of the earth. The earth is rotating, which causes the gravitational constant of the earth to be different at different spots. So when we talk about acceleration, think gravity as well, because gravity is a force that needs acceleration to be a force. So we call this the gravitational constant. So this is not gravity, it's a gravitational constant. So I already talked about it. It's not in the same place everywhere on Earth. So let's move on. Here's an example. Let's pretend that a particle is moving with a velocity described by this equation right here, meaning at a different time we have a different velocity. So there must be an acceleration. Now if there was no t here, meaning velocity would stay the same, so let's say we had v equals 30, then acceleration would be 0, which is totally not the case right here. So the way we do this, we need to find the final velocity first, because recall that the average acceleration equals the final velocity minus the initial velocity. So we get the final velocity by plugging in 2 into this equation. 30 minus 4 times 2 squared, since we're plugging in 2, will give you 30 minus 16 meters per second, which equals 14 meters per second. So that's our final velocity. And sorry, I jumped the gun. I let this one come out too early. But the initial velocity is when we plug in 0. Since the wording said it is from t equals 0 to t equals 2, that's why we're plugging in 2 and 0. So when we plug in 0, we get 30 minus 4 times 0 squared, which is pretty much just 30. So I can already predict that our acceleration is negative, because our final velocity was a smaller value than our initial velocity. We had to slow down for that to be true. So when we plug that stuff in, we get 14 minus 30 divided by 2 minus 0, because that was the time difference, and that will give us a value of negative 8 meters per second squared. Notice how we have meters per second squared. Now the units could have been miles per hour squared. That could have been totally possible too, but SI units, we're talking about meters per second squared. Just like for velocity, SI units is meters per seconds. We're gonna do this next time in our next video, but before we move on, I would like us to do a problem. Let's say Mr. S is driving a car, and he's driving at an initial velocity of 16 miles per hour. Now with all the car safety issues that we have, we always want to make sure that our cars are strong enough, meaning that they have a deceleration that is fairly high. And let's say we can decelerate, and I'm about to go crazy with these units, but we should be fine. Let's say we can decelerate 10 miles per hour per minute. So this will blow your mind, the fact that I have 2 different time units, but that's what these videos are for, just to do things that are unusual. I mean, if I want to follow something that the book does, it would be just the easiest way possible, meters per second times how many seconds. And but if we want to see, we want to make sure that we are flexible enough to do problems that kind of look like this. So the question is, how long will it take for me to stop the car? When we talk about stopping the car, we have an initial velocity, which is a certain speed, but the final velocity should be induced to be 0 miles per hour. And that's because we are stopping. When we are stopping, our velocity is 0. And it doesn't really matter what units they are, it will just be 0. I could have written 0 meters per second, and I could have used that number because 0 meters per second is the same thing as 0 miles per hour. So let's use the equation. Average acceleration equals final velocity minus initial velocity divided by change in time. Time is what we're looking for, so let's just substitute that with t, so I don't have to continuously write change of time. We have an acceleration, almost forgot, it's negative 10 miles per hour per minute, because we're decelerating. We're decelerating 10 miles per hour every minute. That's a terrible car, by the way. That means that we're gonna, I already know that this is gonna be 6 minutes. So imagine you drive a car, and if you're just driving 60 miles per hour, it takes you 6 minutes to stop. Doesn't sound very safe, but then again, I just came up with that problem. So anyways, we will have a final velocity of 0. We will have an initial velocity of 60. And do not forget units, because we want to make sure that we're really good with units and know how to deal with them. The 60 was miles per hour. And times what we're looking for. And that equals an acceleration, which is negative 10 miles per hour per minute. Alrighty, so let's see what we got. We have 60 miles per hour, and we have time, which we're looking for. The miles can cancel, the hours will cancel as well. However, I will not do that because some people might not be clear why this cancels. It is because this is within the denominator. That's within the denominator on the other side, so they typically are able to cancel. But let's not do that because it's not that clear. So let's just pretend I didn't see that these cancel. They will cancel it on. We're looking for time, so let's multiply time on both sides. We end up with negative 10 t, and then the units that we're left with is 1 over hour minute. And on the other side we have 60, and then t is gone now, and we have 1 over hour. Let's multiply hour on both sides, and what do we get? The hour will cancel right here, and I do know my order of operations, so parentheses were needed in this case. The hours will cancel, leaving you with negative 10 time t times 1 over m minutes, which is the units, minutes. These are units right here. Multiplying both sides by minutes, let's multiply by minutes. Don't forget that this hour cancels out this hour. This minute now will cancel this minute, leaving you with negative 10t equaling 60. Was that 60 or was negative 60? It was negative 60. Alright, there we go. That was negative. Missed that negative right there. Make sure you do not make that mistake. And we're left with minutes. And then when you divide both sides by negative 10, you will get t equals 6 minutes. Now, when you do the calculations, you can easily get those, but if not, then just doing it by the book and making sure you don't make any algebraic mistakes, you will get the correct units and the correct answer. Alrighty, so that's that. And maybe do one more example, which is even easier. I just want to make sure that all my students have the ability to kind of look at this video and do problems from the book. So let's do the exact problem, but again, Mr. S was driving, and his initial velocity was 60 meters per second, and then the acceleration was negative 20 meters per second, and seconds squared. And time, we're looking for time. How long will it take for us to get to a final velocity of let's say 10. How long will it take us to get to a final velocity of 10 meters per second? So it gets hard to kind of make up problems while you're teaching them, but you get used to it, I guess. Especially if you're my student. It's not, I don't really have the issue because I'm making these problems. It's the people who has to listen to these videos that may have a opinion about them. Alrighty, so we just rewrite the equation. Make sure that you write that for average. So the average velocity that the car decelerates is 20. So let's make negative 20 meters per second squared. Final velocity is 10 meters per second, and then minus the initial, which is 60 meters per second, and divided by t, which is time. Multiply time on both sides, divide by negative 20. You will get time equaling 10 minus 60 is negative 50. Dividing by negative 20 goes right here. And then the units that you should get, since this is time, is seconds. And let's create a line so we know that this is new stuff. It's not connected to that. Zeros cancel out. You have negative become positive. 5 over 2 is 2.5. So your time is 2.5 seconds. And since seconds is the lowest unit of time, this literally means 2 5/10 of a second. So it's not the weird situation with minutes. If this had been 2.5 minutes, then you would say 2 minutes and 30 seconds, since 0.5 minutes translates to 30 seconds. Alrighty, that's called a day. The book will also have another easy example, but we went from a really difficult situation to a medium, and then from medium to just a textbook kind of problem. So I feel that you should be good for tomorrow's homework session. Have a fantastic day. Bye bye.